Hello, this video is for IXL Activity A1.J.3 Solve one-step linear equations. The three-character code for this activity is Tango X-Ray Juliet. And solving one-step linear equations. Well, let's kind of consider that title for a moment. First of all, linear equations. Linear equations are usually pretty easy to spot. And linear equations are variable will not have an exponent greater than 1. So everything is going to be like k to the first, x to the first, y to the first. You're not going to see any x squared or x cubed type problems with linear equations. So all of our variables are going to be to the first power. And then second of all, the concept of one step. And these are called one-step linear equations because there's just one step to the solution. We're going to use inverse operations in order to find solutions. Remember, solution is any value of the variable that makes the equation true. In inverse operations, inverse meaning opposite. So if it's addition, we're going to use subtraction. If it's subtraction, we're going to use addition. And also, if it's multiplication, then we're going to solve by dividing. And if it's a division issue, then we're going to solve by using the inverse operation of multiplication. So on the first one here, we have k plus 3 equals 5/8. So k plus 3 equals 5.8. So I think I said 5/8 the first time. It's 5.8. So the 3 is tied to the k through addition. So the opposite operation of addition is subtraction. So we're going to subtract. We're going to subtract the very number we wish to get rid of, which is 3. And what we do to one side, we're going to do to the other. And I guess I'll make that 3.0 just since it's decimal to line it up, right? So the positive 3 and the negative 3 are going to create a value of 0, and k plus 0 is just going to give me k. So in all actuality, the 3's kind of cancel each other out, and it leaves us with just k. Now, 5.8 minus 3 is going to be 2.8, and so our solution is 2.8. And we could always plug this back in for k, substitute 2.8. 2.8 plus 3, indeed, that does equal 5.8, so we see that our solution is good to go. On the next one, we have k minus 6. So k minus 6 equals 3. Well, many of you probably think, oh, the answer is 9, because you can figure that one out in your head, right? But if we go through the process, the k is tied to the 6 through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, and what we do to one side, we're going to do to the other. In this case, the k's, or the 6's, are going to cancel each other out, creating a value of 0 and just leaving us with k. So basically, negative 6, positive 6 cancel each other out. And then 3 plus 6 is 9, so in this case, k equals 9. Now we could always plug in our solution there. 9 minus 6 equals 3. Indeed, that is true, so we do have the correct solution. Now, with the subtraction one, I want to point out something, and I want to do this one just a little bit different. We'll come up with the same answer. If we think of this as k, change the sign to addition, and then take the opposite of 6, negative 6, this would be the same problem. All we did is we changed subtraction to addition and took the opposite of the number that follows. Now, if we think of this instead of minus positive 6, think of this as a negative 6, then you're like, okay, well, to get rid of negative 6, then I need a positive 6. And you can see that we're still adding 6 each time, and so those 6's would cancel each other out, leaving us with k, and again, 3 plus 6 would be 9. So I think it's a good concept to get used to because sometimes you will see plus and negative, and this can be confusing for students, so we'll see some problems like that later on. Solve for k. They seem to like to use k a lot on this one, right? So k minus 9 equals 15. So let's go ahead, and the 9 is tied to the k through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, and what we do to one side, we're going to do to the other. The 9's are going to cancel each other out, leaving us with just k, and 15 plus 9 is 24, so k equals 24. And 24 minus 9, does that equal 15? Indeed it does, so we're good to go there. Now I'm going to go ahead and rewrite that minus a positive. Let's go ahead and deal with that a different way. K plus negative 9. I'm just changing the operation from subtraction to addition and then taking the opposite of the number that follows the sign that I changed. And then bringing down our 15. Now let's go ahead to deal with the negative 9. We need a positive 9. And if we're going to add positive 9 to one side, we add it to the other. And the 9s would cancel each other out, leaving us with k, and 15 plus 9, again, would be 24. So either way that you want to do those type problems, totally up to you. You're still going to come up with the correct solution with either process that you use. On the next one, here we have addition, and this is a good one here. That whole, notice because I have a negative 5.3 here, and equals negative 0.9. So now we can see that we need to get a positive 5.3 to get rid of the negative 0.3. So let's go ahead and add 5.3 here. And what we do to one side, we're going to do to the other. And then those negative 5.3 and the positive 5.3 will cancel each other out, leaving me with k equals, and then this is negative 9. So we actually need the difference here, right? One's positive, one's negative. So let's go ahead and subtract one from the other. And whenever we do that, we're going to have to borrow, and that'll be 13 minus 9 is going to be 4, and we borrowed from that, so we got 4 there. So in this case, in the 5.3 has a greater absolute value than the 0.9, so 5.3 is positive, so our answer is going to be positive. So we end up with 4.4. 4.4 is our answer. And does that make sense? If we put in 4.4 up here and then subtract negative 5.39, what do we get? Negative 0.9. Yep, we're taking away more than what we have, so we would definitely end up with a negative number. So we probably got our negative positive signs correct. So those are examples using addition and subtraction. So now let's go ahead and look at some problems in which we have multiplication and division, or multiplication or division, or it's only going to be one or the other in this. All right, here we have 2m equals 4, so this means 2 times m. So we have 2m, that's a sorry looking 2. So we have 2m equals 4. So the 2 is tied to the m through multiplication. So we want to use division. We're going to make it a fraction because all fractions are division problems. We're going to divide by the very number we wish to get rid of, which is 2. And what we do to one side, we're going to do to the other. So the 2's will cancel each other, leaving us with m. And 4 divided by 2 is 2. So m equals 2. And if we substitute 2 in here, 2 times 2 indeed equals 4. In case you're wondering what's happening here with the 2's canceling each other, let's take a look at that in another way. I'm going to go ahead and erase this because I don't want you thinking, oh, what's the magic there? So I have 2m equals 4. And whenever I divide by 2 and I get m, the reason for that is if I have 2m over 2, this is equal to 2 times m over, and I could do 2 times 1, right? 2 times 1 is still 2. I haven't changed the value by multiplying by 1. Now I could do 2 over 2 times m over 1, and that's still the same thing. I just pulled them apart, right? 2 over 2 equals 1, and m divided by 1 equals m, and 1 times m equals m. So that's what's happening. Whenever we say that the 2's cancel each other, we just get m. All this right here is what's going on whenever we do that right there. And then what we do to one side, do to the other. 4 divided by 2 is 2. So if you're wondering why do the 2's cancel each other, this is the reasoning why over here. On the next one, 3q equals 9.69. So the 3 is tied to the q through multiplication. The opposite operation is division. So we're going to divide. We're going to divide by the very number we wish to get rid of, which is 3. And what we do to one side, we do to the other. So the 3's are going to cancel each other, leaving us with q. And then whenever we take 9.69, so let's go ahead and do that on the calculator here, 9.69, we're going to divide it by 3, and that's going to equal 3.23. 3.23. And you could plug that back in. If I multiply that times 3, indeed I come back to the 9.69. Now we're dividing by a negative, right? So we have negative 30 G equals negative 930. Well, the G is tied to the negative 30 through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. So the negative 30s will cancel each other, leaving us with G on the left. And then negative 930, and that's not 930, negative 930 divided by negative 30 is going to give us 31. 31 is our answer. And we would expect a positive number because negative divided by negative equals a positive. On the next one, we have negative 4K. And I just realized we actually had a G over here. They got a whole lot of K variables in this activity. 11.36 equal sign. So negative 4 is tied to the K through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. The negative 4's cancel each other, leaving us with K on the left. And then 11.36 divided by negative 4 is going to give us a negative 2.84. So negative 2.84 is the solution to this equation. Now we have division, right? Remember, all fractions are division problems, right? So J is being divided by 3. So J over 3 equals 3.9. So let's go ahead and write our problem out here. J over 3 equals 3.9. So in this one here, it's the J is tied to the 3 through division. So the inverse operation is multiplication. We're going to multiply by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. So the 3's will cancel each other, leaving us with just the J. And then 3.9 times 3 is going to give us 11.7. 11.7. So 11.7 is our solution. Now, if you're wondering, how is it these 3's cancel and I just end up with J? You know, the numerator just ends up here by itself. Let's go ahead and look at that and see how that works out. So I have J over 3 equals 3.9. And I don't like the 3.9. Probably do a little better on that. 3.9. There we go. So whenever we multiply by 3, I'm going to go ahead and write this 3 as a fraction over here. And over here, I'm just going to write it as a whole number over here. They're both both values have a value of 3. Now, the reason we end up with just J by itself, I'm going to do it up over here on the side. 3 over 1 times J over 3. This would equal 3 times J and 1 times 3. Well, now, in the denominator, I'm going to go ahead and switch the positioning of the 1 and the 3, commutative property of multiplication. So I'll end up with 3 times J over 3 times 1. Well, I could then pull it apart. 3 over 3 times J over 1. 3 over 3 equals 1. J over 1 equals J. And 1 times J equals J. So we just end up with the J down here. That's why the 3's cancel each other and leave us with just J. And then again, 3.9 times 3 is going to be 11.7. So if you're wondering how is it that the 3's cancel each other in the numerator, whatever the numerator is, just pops out down here by itself, it's because of all of this stuff that's going on over here. All right, 1.9 equals R over 2. Or R divided by 2. So the R is tied to the 2 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. The 2's are going to cancel each other, leaving us with R on the right. And then 1.9 times 2 is going to give me 3.8. So R equals 3.8. And if you like your variables on the right, then you could just switch them around to each side, and R equals 3.8 is the same thing. Here we have R over negative 10, or R being divided by negative 10 equals negative 5. So R over negative 10 equals negative 5. So R is tied to the negative 10 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, and what we do to one side, we're going to do to the other. So the negative 10s will cancel each other out, leaving us with r, and negative 5 times negative 10 is going to be a positive 50. Right? Negative times negative equals positive. Over here we have b over negative 20 equals 25. So the b is being divided by negative 20. The opposite operation of division is multiplication. We're going to multiply by the very number we wish to get rid of, which is negative 20. And what we do to one side, we're going to do to the other. The negative 20s will cancel each other, leaving us with b. And 25 times negative 20 is going to give us a value of negative 500. So negative 500. Now I've included these two problems here, especially this one on the left, because it's kind of a tricky one. You just got this negative sign in front of the f. So I'm going to rewrite this negative 6.1 equals negative f. Now, if we think about this, I could change that value of negative f, and I could write it as negative 1 times f, right? The value would still be the same. If I multiply f times negative 1, I would get negative f. So if we think of it that way, then the negative 1 is tied through the f through multiplication. We're going to divide by the number we wish to get rid of, which is negative 1. What we do to one side, we're going to do to the other. The negative 1s cancel each other, leaving us with f. And negative divided by negative is positive. 6.1 divided by 1 is 6.1. So we end up with 6.1. Now another way to do this, and I like to think of it instead of dividing by 1, I like to think of it as multiplying by negative 1. So let's see how that works. So if I multiply negative 1 times negative 6.1, and I multiply negative f by negative 1, then I end up with negative f times negative 1 is going to be positive f. Negative 1 times negative 6.1 is going to be a positive 6.1. So anytime that you have a negative variable, and you're going to end up with problems like that, you're going to work out a longer equation, and you're going to end up with something like negative x equals 53, right? And you can't have your answer in the form of a negative x. It needs to be a positive x. So you're just going to change the left side from negative to positive, and then take the opposite of the right side. In this case would be negative 53. So whenever you do that, you're basically doing exactly what we did in this problem here. And then finally, for the final problem in this video, k plus negative 5.3 equals, and I did this one, didn't I? 5.309? I did, back here. Okay, so we're good to go on that. Already did that question. So I guess we could, no, I'm not going to finish it up. So that concludes all of my examples for IXL A1.J.3 Solve one-step linear equations. Good luck with your activity.